Hello, welcome to my very first video on this channel. My name is Professor Damien. Well, quote unquote professor. I'm not actually. I'm just a student. I'm still learning calculus. I just This is just more like a passion kind of project thing where I want to learn how to teach math. This being the case, my first video or the first few videos that I make might not be the best, and they might not be as clear as possible, but I'm trying. So if you do stick around to this whole video, thank you very much. I also want to preface this that if you there are any if I do any mistakes and you need further clarifications, please drop down a comment. I'll try and explain it as best as I can. But anyways, let me get into the actual meat of the video. So today I'm going to be talking about limits on a graph. Um, and the big idea is, what is a limit, right? So right here is the symbolic definition of a limit. So right here we just have the limit, well, LIM stands for limit. Here we have the x variable, which just simply is, the x input that we have in our functions. You can see right here, right? And this arrow, or this whole entire thing basically means x approaching the value of a. So you can see that these two correlate with each other. So like, that's a terrible arrow. I'm sorry, I'm using MS Paint and I'm using a mouse, so not the best coordination I would say. And so let me give you a graphical example of this, right? Oopsie daisy, that's not what I want. So right here is, or let me show you what we have right here. So this right here is the limit of x squared as x is approaching 2. So to find the limit of this, we basically put or input the a value, here you see, right here, into, you see that they're all connected. So we input the 2 into the x, we square because that's what's inside of this. Then that gives us the limit of 4. Oh, I forgot to even, I don't know if I did, but this right here is the limit. L stands for the limit, so 4 is our limit, and it's also our y value. So let me show you this. So on a graph, this is basically the same thing. You'll see that this point right here is 2 is x2 y4. And now let's say we didn't have any of that, right? We just we didn't have this point, but we know we want to get to x approaching 2. So you see, like let's say we start from here, right? Let's say you're a little human person and you're running on this parabola. You want to run to the to x is equal to 2, which is right over here. Let me actually add a little line to show you. So you want to get to this point right here, right? So you're running from this side, and you approach x is equal to 2. Then you approach from up here, and you want to go down. You want to slide down to x is equal to 2. So on a graph, that's how you would find the limit. So let's just throw something out there. Let's say we're we are the limit of x squared as x is approaching the x value of 1, which is right here. Okay, so in order to do this, we got to make sure that we're approaching it from both sides. Now, that's one of the main things, that we have to approach from the top and from the bottom. So I'm gonna just do like a little example of this. So we're approaching from the top real quick, and it's 1. Whoa, what a surprise. It's not like, super intuitive. And then now, if you're going in from the left side, oh wow, it's also 1. Now, why does that matter? really. Like, obviously, I can see that it's approaching 1 from both sides. Like, I don't need you to tell me, right? And you don't for graphs like these or equations like these, or sorry, functions like these. Now, let me show you something like this. Now, this right here is a piecewise function. And we have 2 little points. So you'll notice something, that there's a huge gap or huge gap in between these two, you know? So let's say you're approaching from the right side, you're like running across this side and you're approaching, then you get to the point 5, 5. Now you're like, okay, now I want to approach from the left side and see if it's the same thing. Wrong. It is not the same thing. So if you were to do this, right, I'm not going to write down the whole piecewise function on MS Paint, but basically, if you were to just have the regular limit, this would be undefined because it's two completely different equation or different functions, because well, it's the same function, but it's two different equations inside that function. That causes this huge gap in between. So if you want it to be, if you want it to be perfect, right, you would have to be the limit of f of x as x is approaching a from either the negative or the positive side. Now we're going to go with the positive side first. So if we're approaching, or sorry, the negative side, we're going to go with the negative side first. So basically, if you're approaching from the negative side, you're approaching from this side. So you're approaching from left to right. And you'll notice that as we approach from the left side, that our y value is 3. Now, let's say we're approaching from the positive side. Oh my God, that's a terrible circle. If we're approaching from the positive side, which is just from right to left, that we'll see that our y value is in fact 5, which is our limit 5. Now we're going to go into something called the infinite limit. So what the heck is that? What does that even mean? So you'll notice right here we have the I don't know if it's inside the video or not, but we have the function 2 over x. And one of the main things that you'll learn is that you cannot divide anything by 0 because it is indeterminate, because it's just, you know, how many zeros can go into 2? Who knows? Like, it's indeterminate, it doesn't exist. So you'll notice that right here, as x is equal to 0, this right here goes on forever and ever and ever and ever, and it gets smaller and smaller and smaller and smaller as time goes on, but it will never touch this x is equal to 0. And this right here is called a vertical asymptote. It basically means that it's getting as close as possible to whatever value or whatever point it is without ever actually touching it, which is kind of cool if you think about it. So you'll notice something too, since it's never touching anything and just going up and up and up and up forever for an infinite amount of time, that there's no clear limit definition or value. So how would we write this? So, and another thing too is that you'll notice that there's no like bridge between these two functions, or between this function, right? There's no clear like line going to this one or this one going to that one. So that means we then again also have to use the limit of x approaching a from either the positive or negative side. So let me do that again. So oops, oh wait, I could just bring it back. Okay, so let's say we're gonna get rid of this side real quick. Whoa, that is way too small. So we're approaching from the negative side, right? Or, you know, let me just erase all of that actually. And let me just rewrite it again. So we're gonna have 0 approaching from the negative side, right? So we're approaching 0 from the negative side, so we're going from left to right. And you'll notice same thing goes down forever and ever and ever. And since it's going down into the negatives forever and ever and ever, it is going to be negative infinity. So that is the limit. The limit is equal to negative infinity. You can also write it as the y value is negative infinity as well. Okay, so we have that. Now let's say we're approaching from the positive side now, right? So we're going from right to the left. So you're running up this hill. You're on like a rocket ship now because you're going straight up into the air. And you'll notice that it's going up positively forever and ever. Now, what do you guys think it is? Positive infinity. Isn't that just mind-blowing? Okay, so we have that now. Now, we're going to go over just one more. This is going to involve a hole. So, like, I see all of this stuff, right? Like we see this line. Oh, wow, that's a perfect line and it's perfectly normal. It's a perfect, you know? Oh, wow. Surely there's no gaps or nothing, right? Oh my God. It's undefined at one specific point. And that point is when x is equal to 3, as you can see right here. X is equal to 3, and then you'll see that it's undefined. Now, on a graph, we can obviously see that the limit is 6, right? Matter of fact, let me show you. So that's our hole right there, but I'm going to get rid of the label. Or no, I'm going to keep the label, but I'm just going to, you see? Whoa. So obviously we see it's 6, but if we were to determine this algebraically, it'd be completely different. I will show you guys that in a different video though. But you'll see it follows the same rules. We gotta approach it from both the left and the right side. And if it was like one of these functions again, and there was a hole somewhere between either one of these two, you'd still have to use, approaching from the right side, approaching from the left side, all that stuff. So yeah, that's basically it. Um, Thank you guys if you watched through all of this. I hope it wasn't too long. I mean, I can see that's like 13 minutes long, but I'm sorry. These videos will get faster and quicker as time goes on, and maybe I'll start making scripts because this one was completely unscripted. Well, kind of. I did like 5 different test videos of this beforehand, and the audio didn't work at all. So I wasted like 15 minutes on one video and just for the audio not to work at all. So I hope the audio works in this one, please. But thank you, everyone. Hope you guys have a good rest of your day. Bye bye.